Hello everyone, welcome back to the channel. This is Shailesh Research. Today I am going to discuss one of the most important topic of the entire physical chemistry, that is atomic mass and molecular mass. I am damn sure if you could not able to remember, understand these things now, you could not able to solve a single question from the physical chemistry. My humble request, please focus more on this. Alright, let's go with the first topic, that is atomic mass. Here generally we are going to discuss the atomic mass with respect to relative atomic mass. What do you mean by that? Before that, you need to understand one value, that is one atomic unit. One atomic mass unit, that is equal to 1.66 into 10 to the power minus 24 gram. Always keep in mind that before the advent of the mass spectroscopy for determining the atomic masses accurately, scientists were determining the mass of one atom related to another by experimental means. इसका मतलब है हाइड्रोजन को एक रेफरेंस मान के hydrogen was being lightest atom was taken initially as a reference, but it was not working properly because it was the lightest element. Later, International Union of Chemists, they selected the most stable isotope of the entire periodic table, that is carbon. In that carbon 12 isotope they have chosen because it shows most stability, or more stability it shown. Therefore they choose that one with respect to this carbon 12 isotope के point of view से दूसरा एलिमेंट अदर एलिमेंट का मास फाइंड आउट करने के लिए हमको हेल्प हो जाता है. इसीलिए आई एम ट्राइंग टू कंपेयर, सो रिलेटिव, therefore we are using the word relative atomic mass. I hope you understood. In this system, carbon 12 assigned as a mass of exactly 12 atomic mass unit. Carbon 12 assigned as 12 atomic mass unit, that is only we call it as AMU. And masses of all other atoms are given relative to this standard value. So you have to remember, we have simple definition also. One atomic mass, if I am mentioning here, one atomic mass unit is nothing but a mass exactly equal to 1/12 mass of इसका most stable element carbon 12 atom. This only we call it as relative atomic mass also. We have to remember 1 AMU. So relative atomic mass is equal to what? We have simple formula, we need to remember that one. Mass of atom of the element divided by 1/12 into mass of atom carbon 12. This is how we will get relative atomic mass. Then what do you mean by mass of one atom of the element, and what do you mean by mass of carbon 12 isotope? We know all the values, right? But if you could not able to remember all these values, you have to remember that relative atomic mass, that is RAM, is equal to, if I am trying to simplify mass of atom of the element divided by 1/12 mass of a carbon atom, we will get total nucleons. If you are interested how we got total nucleons, you just comment, then only I can explain, simply no need to waste the time. Then total nucleons is nothing but what? It is number of protons and number of neutrons. These sum only we will get relative atomic mass, that is total nucleons. When it comes to the relative atomic weight, we have a definition. The atomic mass of an element tell us how many atoms of element is heavier than 1/12 of an atom of carbon 12 isotope. So why we are taking only carbon 12 isotope only? Why can't we take helium? Why can't we take other another elements also? Here most important thing is that carbon 12 isotope is a more stable element in the entire periodic table. We know isotope are nothing but atomic number same, different mass, right? C12, C13, C14. Among these also we have C12 is the most stable one. Done? That is the first definition of relative atomic mass. Here, now we will understand some example how to find out the relative atomic mass. We know that proton plus neutron is nothing but what? Total nucleons. We know already about this, right? Total nucleons. Total nucleons is nothing but what? It is nothing but relative atomic mass, that is RAM. Let's understand with the example. Here we have hydrogen. Okay, we know atomic number and its protons kitna hai, neutrons kitna hai, we know all those things. First hydrogen, when it comes, we know H atomic number 1, mass number 1, right? So here proton कितना है 1, इलेक्ट्रॉन कितना हो सॉरी न्यूट्रॉन कितना हो सकता है, that is also 0, 1 minus 1, no, right? Now total it become how much, 1 plus 0 is nothing but 1. So relative atomic mass for hydrogen is how much, 1. For helium here we have 2 protons and 2 neutrons. How neutrons 2, 4 minus 2, no, right? 2 plus 2 nothing but 4 nucleons. 4 nucleon is nothing but relative atomic mass. Carbon 6 plus 6, 12, nitrogen 7 plus 7, 14, oxygen 8 plus 8, 16. Like this we have to find out. But here in sodium 11 protons, 12 neutrons. This is how we used to find out the relative atomic mass. Now we will understand some important properties related to relative atomic mass. When I am mentioning relative atomic mass, here we don't have any unit actually, right? Why? Because relative atomic mass is nothing but mass of an element divided by 1 by 12th of mass of carbon 12. Therefore gram we will get cancel each other, unitless वो बन जाता है. Therefore relative atomic mass is unitless. Second point, irrespective of the name of the sample, if the weight are same, the number of nucleons are same. उससे पहले आप लोग और एक बार याद रखना है, weight is determined by its nucleons, not nucleus. Always keep in mind this point. कौन सा भी एलिमेंट का अगर आप लोगों को वेट फाइंड आउट करना है तो यू हैव टू फाइंड आउट द total number of nucleons only, right? Here we will understand some example. With the above statement we need to remember कौन सा भी वेट ऑफ द एलिमेंट फाइंड आउट करना है तो न्यूक्लियॉन्स का रोल इंपॉर्टेंट है. न्यूक्लियॉन कैसे फाइंड आउट करते हैं, प्रोटॉन्स प्लस न्यूट्रॉन, राइट? हियर एग्जांपल आप देखिए, 50 ग्राम ऑफ शुगर इज देयर, 50 ग्राम ऑफ वाटर, 50 ग्राम ऑफ कैल्शियम कार्बोनेट. What is happening here? Number of nucleon is common in these 3 sample, right? Nucleons are same है. अगर nucleon same है तो then weight of the sample is going to be same only. Therefore 50 ग्राम of sugar, water, calcium carbonate का weight क्या रहता है यहाँ पर, same ही रहता है. We have to remember this one because nucleon same रहता है यहाँ पर.